My name is Mark Denton, and I'm going to present my project for MAE ECE 535. It is on a TMR sensor used for linear position. So TMR stands for tunneling magnetoresistance. So first, a little bit about magnetoresistance. It's a part of the field of study of spintronics. And so magnetoresistance, the definition of it is the property of a device to change electrical value under a magnetic field. And so electrons have two key parameters, spin and charge, and spintronics is obviously focused on spin. So when electrons are traveling inside of a conductive material, they can scatter. And also, when electrons are traveling inside of a ferromagnetic material, the spin will increase or decrease the scattering probability. This increase or decrease in the scattering probability is the magnetoresistance theory. And so you can see on the right there's the two ways in which electrons can be aligned with magnetic fields. So TMR specifically is the latest and greatest type of magnetoresistive technology. As you can see on the right, there's a graph that shows magnetic field versus resistance. And you can see the element. There's a top and bottom layer, which is a ferromagnetic material, and then a thin non-conductive layer in the middle, which is very thin, typically a few nanometers thick. So what happens is, as you change the magnetic field, the electrical resistance in the free layer, the top layer, changes, and that causes you to be able to sense the magnetic field. So here's my project. If you see in the bottom photo, there's a linear rod with a bearing mounted to it, and there's a permanent magnet mounted on the right side of that bearing. And so as you see on the left also, there's a small green PCB, and that's where my TMR sensor is mounted. And so as you move back and forth, the linear bearing changes the magnetic field, and that gives you a linear distance. So I take that data from the TMR sensor, send it to the Arduino, and then convert that to the distance and output that on the LCD screen. So here's my actual demo project. Main components over here on the left is the Arduino board, the LCD screen. The TMR sensor is mounted here on the far left. That's the breakout board with the connections back. And then I have my linear slide here. It's got the linear bearing on it with a permanent magnet mounted to it. And so as you can see, the TMR sensor is picking up the permanent magnet field. If you zoom in here to the LCD, you'll see the readout of millitesla. And as I move this back and forth, it changes. And so this is basically, I'm converting the millitesla. I'm sort of converting that to a linear distance, sort of interpolating between points. And so if I go to, like, say 1 inch, you'll see 0.97. Let's see, go to like 2 inches, 0.196, 2.5, 2.45. As you get out further than about 2.5 inches, it kind of gets out of its precision range. The span of it isn't nearly as much. From 0, which is 1.88 millitesla, to 2.5, which is 0.4. Pretty large span relative to the last 1.5 inches, which is only 0.2 millitesla versus like 1.4. So, but yep, that's my sensor.